Before we start anything, let's think about how we can solve this question. Here you can see in the numerator value sin squared x and in the denominator value 3 plus 4 cos x. If we can express the numerator value in terms of the denominator, then we can divide numerator values separately, and after that we can consider the integral sign separately. To simplify constant over 3 plus 4 cos x part, we can use the standard substitution u equal tan x over 2. Clear? Let's jump into the question. Numerator value sin squared x we can write as 1 minus cos squared x. After that, we can multiply denominator and numerator value from 16. Now, in the numerator, we have 16 minus 16 cos squared x. 16 value we can write as 7 plus 9. Now, 9 value we can write as 3 squared, and 16 cos squared x value we can write as 4 cos x perfect squared. 3 squared minus 4 cos x perfect squared, just like a squared minus b squared. A squared minus b squared equals a plus b into a minus b. So in here 3 squared minus 4 cos x perfect squared we can write as 3 plus 4 cos x into 3 minus 4 cos x. Now instead of numerator value sin squared x, we can substitute 1 over 16 within bracket 7 plus 3 plus 4 cos x into 3 minus 4 cos x value. Numerator value 1 over 16 is a constant, so we can bring 1 over 16 value outside of the integral. After that, we can divide numerator values from denominator value separately. First one, 7 over 3 plus 4 cos x. Second one, 3 plus 4 cos x into 3 minus 4 cos x over 3 plus 4 cos x. Now we can cancel out numerator value 3 plus 4 cos x and denominator value 3 plus 4 cos x. After that, we can get integral sign separately. First one, 7 over 3 plus 4 cos x. Second one, integral 3. Third one, integral 4 cos x. We can bring constant value outside of the integral. Integral 1 value we can write as x. Integral cos x value we can write as sin x. After that, we can substitute upper limit and lower limit for these answers and get the result 3 pi over 2 minus 4. Now we need to get the integral value of 1 over 3 plus 4 cos x. To simplify this integral part, we can use substitution method. We can substitute u as tan x over 2. Then differentiation with respect to x. Differentiation of the u value equals du over dx. Differentiation of the tan x over 2 value we can write as sec squared x over 2. Differentiation of the x over 2 value we can write as half into 1 or half. After that, we can cross multiply denominator value dx. Now we can subject dx as 2 du over sec squared x over 2. Sec squared x over 2 we can write as 1 plus tan squared x over 2 because sec squared theta equals 1 plus tan squared theta. Since u equals tan x over 2, we can substitute instead of tan x over 2 value u. Then we have dx equal 2 du over 1 plus u squared. Now we need to change upper limit and lower limit corresponding to u variable. First one, upper limit. When x equal to 0, u equal tan 0 over 2. It is equals tan 0. Tan 0 equals 0. Then u equals to 0. Second one, upper limit. When x equal to pi over 2, u equal tan pi over 2 over 2. It is equal to tan pi over 4. Tan pi over 4 means tan 45. Value of tan 45 is 1. So, u equal to 1. Further, cos x equal 1 minus tan squared x over 2 over 1 plus tan squared x over 2. So, instead of tan x over 2 value, we can substitute u. Then, cos x equals 1 minus u square over 1 plus u squared. Let's move to the integration part. Now, we have lower limit 0, upper limit 1. Instead of cos x term, we can substitute 1 minus u square over 1 plus u square. Instead of dx value, we can substitute 2 du over 1 plus u square value. Now we can get a common denominator in the denominator. It is 1 plus u squared. After that, denominator of the denominator value we can write as numerator. Then we can cancel out 1 plus u squared, numerator value and denominator value 1 plus u squared. 2 is a constant, so we can bring 2 outside of the integral. Denominator value we can simplify and it is equals 7 minus u squared. 7 minus u squared we can write as root 7 perfect squared minus u squared. After that, we can factorize using difference of 2 squared. It is equals root 7 minus u into root 7 plus u. To simplify this integral, we can use partial fractions. 1 over root 7 minus u into root 7 plus u value we can write as 1 over 2 root 7 over root 7 minus u plus 1 over 2 root 7 over root 7 plus u using partial fractions. After that, we can get 1 over 2 root 7 value as a constant value. So, we have 1 over root 7 minus u plus 1 over root 7 plus u. Now we can consider integral sign separately. Integral of 1 over root 7 minus u value we can write as ln modulus root 7 minus u over minus 1. Here coefficient of u equals minus 1. That's why we divide this answer from minus 1. Integral of 1 over root 7 plus u equals ln modulus root 7 plus u. Now we need to substitute upper limit and lower limit for these answers. Then we can get the result minus ln root 7 minus 1 plus ln root 7 plus ln root 7 plus 1 minus ln root 7. After that, we can cancel out ln root 7 positive value and negative value. Ln root 7 plus 1 minus ln root 7 minus 1 value just like ln a minus ln b. So we can write ln a minus ln b as ln a over b. In this case, ln root 7 plus 1 over root 7 minus 1. Let's substitute this value for our final answer. Then we can write 1 over 16 within bracket 7 into 1 over root 7 ln root 7 plus 1 over root 7 minus 1 plus 3 pi over 2 minus 4. 7 value we can write as root 7 into root 7. After that we can cancel out numerator root 7 value and denominator root 7 value. Now we have final answer as 1 over 16 within bracket root 7 ln root 7 plus 1 over root 7 minus 1 plus 3 pi over 2 minus 4.